Okay, so the last thing that we're going to look at is 0 and negative exponents. So we're going to just start with a little experiment that's not on your notes page. We want to find the quotients of each of these. So we're going to use our quotient of powers law, so dividing powers. The way we're going to do that is just by going through and subtracting their exponents. So 3 minus 3 is 0. So we get 2 to the 0 power. And then we see 2 minus 2 is 0. So we get 4 to the 0 power. And then 4 minus 4 is 0. So we get x to the 0 power. And when we're looking at things like x to the 0, what we can conclude about a to the 0, that means we want none of the bases. And we know that anytime that we are getting rid of a base, if I did like 2 divided by 2 here, that would end up getting me 1. So 2 to the 0 is 1, 4 to the 0 is 1, and x to the 0 is 1. Okay. And so let's do the same thing, finding the quotient of these guys. So again, we've got 2 minus 4, which gives us 2 to the negative second, but remember there are more exponents in the denominator. So if I was to do this, this is really equal to 1 over 2 to the second. Same thing here, I do 1 minus 2, and I get 4 to the negative first, but that is equal to 1 over 4. And then 2 minus 4, again, gets me x to the negative second, but that's equal to 1 over x squared. The reason why is if I go ahead and write out the factors, and then I simplify one factor with a matching factor in the numerator and denominator, so these two simplify, I'm left with 2 2's in the denominator, which is 2 squared. So let's look at that for all of them. Same thing here, I've got 4 over 4 times 4. One of the 4's simplify, and I'm left with 1 4 in the denominator. Okay, same thing here, let's take a look, x times x, and I've got x times x times x times x in the denominator, and x simplifies, and a pair of x's simplify, I'm left with x, 2 x's in the denominator, which is x squared. So what we can conclude about a to the negative n is a to the negative n is just the same thing as having 1 over a to the positive n. Okay, so let's take a look at those definitions as laws. So if I have a to the 0, that's always going to equal 1 for a being anything, any number but 0. Okay, a can't equal 0. If it equals anything but 0, then that means it's always going to simplify to the number 1. Okay? With a to the negative n, if I have a to the negative n, it can be rewritten as 1 over a to the n. Again, same thing. A is any number but 0. Okay, so a to the negative n is what we call the reciprocal of a to the n. So that means it ends up being in the numerator as opposed to the denominator, or the denominator as opposed to the numerator. Okay. The last thing is a to the n is the reciprocal of 1 over a to the negative n. Okay, so they are reciprocals of each other. A to the n is the reciprocal of a to the negative n. Again, a has to be any number but 0. Okay, they're reciprocals of each other in the sense that you can take one and rewrite it in the denominator with the opposite exponent. Okay, so let's do some examples. So for the first example, I have my first law, which is a to the 0. We know anything to the 0 power is just 1, so that can simplify to 1. The next law, we're looking at negative exponents, and it has a negative exponent that we want to simplify so that it has all positives. Simplest exponential form is having exponents with all positives. So we're going to rewrite this as its reciprocal, which is 1 over 4 to the positive 3. Again, if it asks for simplified, then you're going to go ahead and simplify 4 to the 3rd. But if it asks for simplest exponential form, then you're just writing it using exponents. Okay. Here we're using the the law of an exponent of 0, so negative 7 to the 0 is 1 because my base is something other than 0. Okay, here we're going to use two properties. So we're using the raising a quotient to a power property to start with. So this negative 3 has to go both to the 3 and the 2. So we're going to rewrite this as 3 to the negative 3 over 2 to the negative 2. And then we're going to go ahead and use the reciprocal property. So a to the negative n using negative exponents. That means the 3 to the negative third is in the numerator now, which means it's going to be written in the denominator with a positive exponent. And then 2 to the negative 2 is written in the denominator now, so it's going to be written in the numerator. Oh, I'm sorry, to the negative 3, not to the negative 2. It's going to be written in the numerator with a positive exponent. That's simplified exponential form. If they ask for just simplified, then you would go ahead and do 2 cubed in your calculator and 3 cubed in your calculator and see what you get. All right, so the next one, we have negative exponents as well. So if I am doing negative exponents, that means they are the reciprocal of each other. I have 2 to the negative 3 in the denominator. So what I'm going to do is I'm going to raise that to the numerator with a positive exponent. So that means I have 2 cubed over 1, which is just the same thing as 2 cubed. Okay, here I have a base of 0. Our law said that we can use these as long as a is not 0, because a is 0 here. That means it is not possible, or it doesn't give you a real number. So we just use an empty set to show that that is not possible. Okay, then we're going to look at the next one. So we need to do our product of powers first and multiply or add the 16 and the negative 4, because I've got two powers or two bases that are the same. I get 13 to the second. Another way you can do that is taking the 13 to the negative 14th and putting it in the denominator. So you've got 13 to the 16 over 13 to the 14, and then you would use your division property of powers, and you would do 16 minus 14, which then gets you 2 as well. Okay, so either way would work, either just adding those exponents or writing the 13 to the negative 4th in the denominator and then subtracting the exponents. Okay, so same thing here. We can either use the product of powers property first and do negative 4 plus 4. That gets you 6 to the 0. And then we would use the 0 exponent law, which gets us 1. Another way you could do this again is by taking these guys and writing the first one in the denominator and the second power in the numerator, and then using your subtraction property 4 minus 4 to get you 0. So one way or the other does not matter to me. Okay, so here we're going to use the power raised to power property to start with. So I've got negative 2 raised to 2. We multiply those together. We get 4 to the negative 4th power. And then I need to use my negative exponent law to write that base in the denominator using a positive exponent. So 1 over 4 to the 4th. Okay. Last two examples, I've got negative or 5 to the negative 1st, so I need to first write this in the denominator of the fraction. So this is equal to 1. When I get rid of something in the numerator, if nothing is there, I put a 1 as a placeholder. I put 5 to the 1st in the denominator, and then I'm going to multiply it by 5 to the 2nd, which was already there. Then I need to use my product of powers property and take the exponents and add them together. So I've got 1 over 5 to the 3rd as the simplified exponent form. Okay, here we're going to use our product of powers property first and do 5 plus 5, and we get negative 3 to the 0. And then we're going to use the 0 exponent power, the 0 exponent property, and do negative 3 to the 0 power, which gets you 1. Okay, so a few more examples. Let's just go through these. We've got first using our product raised to a power property. So I need to do 2 to the 3rd, and then x to the 3rd, and then I use my power raised to a power property, and I need to do y to the negative 5th raised to the 3rd by multiplying. So that's going to be y to the negative 15th. then I need to go ahead and take my negative exponent power property and take that y to the 15th and move it to the denominator. So I've got 2 cubed over x cubed, or 2 cubed times x cubed over y to the 15th as your simplified exponential version. Okay, so we're going to do the same thing here. We've got a product raised to a power. We're going to take each part of our product and we're going to give it the exponent of 3. So we've got 3 to the third. And then we're going to take our exponents, -2 and 3, and multiply those together because that's a power raised to a power. We get m to the -6. Then we'll also take 3 and 3 and multiply those together, and we get n to the 9th. Then we need to use our negative exponent law and take that m to the -6th and move it to the denominator. So we still have 3 to the third and n to the 9th in the numerator, but we've got m to the 6th in the denominator. That is our simplified exponential form. Okay, so on n, first thing we got to do is we got to get rid of these grouping symbols. So we're going to use our product raised to a power property. We're going to give -2 to both of those. We've got 2 to the -2 and x to the -2, and then we still have y to the 5th in the numerator, and that's over -4x squared y squared. We're going to use our negative exponent laws, and we're going to bring these guys down. So we still have -4. We're going to multiply that by what's going to now be 2 squared. That's the positive version of this. And then we're going to take this x to the -2 and make it x to the +2. That's going to be multiplied the x squared that was already there. And then the y to the 5th is going to stay in the numerator, and the y squared is in the denominator. So this is the denominator of that fraction. We said the numerator remains y to the 5th. Then we're going to simplify any of these things that we can. So I know 2 squared is 4, and then I can do 4 times -4, which is -16. So we get y to the 5th over -16. Then we have a product of powers property here with x squared and x squared. So we add their two exponents and we get x to the 4th. And then we have y to the 2nd. And then I check for division. I've got y to the 5th over y to the 2nd. They're the same base. So I subtract their exponents. I get y to the 3rd. Because the 5 had more, that y to the 3rd is going to stay in the numerator. And then we're going to have no y's in the denominator. So we've got y to the 3rd over -16 x to the 4th as my simplified exponential form. Okay, for the next one, again, we get rid of the parentheses first. So we're going to have -5 squared x squared y squared, and then y to the -4th, all over -10 x cubed y to the -8. Okay, so what I'd like to do first is I'd like to use, and this is, there's multiple ways you can do this. You can use any of the properties in any order as long as you get rid of the grouping symbols first. I like to just simplify my products up in the numerator or the denominator before I start doing division. So I have y squared and y to the -4th. I add those two together. The -5 squared stays the same. I've got x squared, and this is now y to the -2nd. And I have that over -10 x cubed y to the -8. Okay, now I like to start seeing if I can do some division. So I know that -5 squared is actually 25. And if I do 25 divided by -10 and simplify that fraction, that ends up getting me a negative, what am I doing? -5 over 2. So -5 is going to stay in the numerator, and then 2 is going to be in the denominator. Then I look at my x's, and I have a 2 minus a 3, which gets me -1. But if I have x to the -1 in the numerator, I have to use the negative exponent law to put that x as a positive exponent in the denominator. We know anything to the first power is just itself, so I'm just going to write that as x instead of x to the first. And then I do my -2 minus my -8. Make sure that you know that that subtraction needs to be there even if there's a negative exponent in the denominator. When I do that, I end up getting y to the 6th. Because that y to the 6th is positive and -2 is larger than -8, I'm going to keep that y to the 6th in the numerator. So my simplified version is -5 y to the 6th over 2x. Okay, so just some tips real quick for you to copy down. If you forget the rules, just recreate them using a simple example like a base of 2. So, 2 squared times 2 cubed. If you forget what you do with them, go ahead and write out all the factors and see what you get when you add all those factors together. So I have 1, 2, 3, 4, 5 2's there, which means that this is going to get me 2 to the 5th. So that shows me that I would add their exponents. That's recreating the rule with a simple example. When you're raising a product to a power, be careful with negative signs. So if we have a negative sign out front and then we've got a product raised to the power, that negative sign does not get the power. If we have a negative sign inside with a product raised to a power, that negative sign does get the power, so the negative needs to stay in parentheses when you give it to all the factors. Okay? Anytime you're raising a negative to an even power, so that's 2, 4, 6, 8, 10, etc., you're always going to have a result of a positive value. But remember, that's only if the negative is grouped with the number and it's inside parentheses being raised to a power. Don't work on autopilot. Really make sure that you think about whether or not your answer makes sense and whether or not it makes sense to add or multiply based on what your expanded form is. Also think about your signs when you have negative expressions. Be very careful with those. Okay, so go ahead and try your practice. Let us know if you have any questions.